Hello, my name is Stephen Crow. This is FTH 202-518-99, the revolver course for the Taurus 856. It's March 3rd. This is assignment number 3. So first thing we'll do is show that the weapon's clear. All chambers clear. Pop this side plate off real quick. Let me drop the camera down. There we go. Alright, pry this side plate off real quick. There we go. So, first thing I'll do is identify the components on the inside whenever we're talking about the cycle of operations. We've got the hand, the sear is down here, the hammer strut is right here, and the cylinder stop is, I'm sorry, my hand's covering it. Cylinder stop is right there. So cycle of operations, the first two are pretty easy. Feeding, chambering, both have to do with the cylinder. Whenever it comes to the firing part, you know, I think that if there's going to be an issue when it comes to firing, if it's going to involve the hand, it's going to have something to do with the hand not being able to rotate the cylinder. And, you know, I typically think that that's going to be from, you know, either the part's excessively worn, so it's unable to connect with the trigger like it's supposed to, or the top part of the hand could be worn and it's not able to rotate the cylinder like it's supposed to. The sear, same thing. Whenever you're going towards the locking phase, if you're pulling on the trigger and you're not able to appropriately engage the sear on the hammer strut, then you're going to run into some issues when you're trying to get the cylinder to rotate and get that locking phase to where the chamber lines up with the bore correctly. You know, anything else on the internals that could have an issue, I mean, I think the you know, the cylinder stop, if the cylinder stop is worn out, or if there's some sort of a malfunction between the top of the trigger and the cylinder stop and the hammer, or the cylinder is unable to rotate, that's also going to be an issue with locking. And then firing would all have to do with, you know, the firing pin and the hammer and the engagement of that transfer bar on that firing pin. So that's where I think that if there is going to be an issue, that's where it's going to be. And then let's pop this cylinder out real quick so we can measure the bore. So release that. Drop all that out. Got my flag already on my cleaning rod that rotates. We can throw the cleaning patch on there. Trying to get a little bit of build up on that cleaning patch so that it causes enough friction. And what's going to happen here, I've already done this morning, so I've got my mark on here already on my cleaning rod. I want to cause enough friction to where this will actually still engage and rotate, but not so much friction that it's not able to rotate and I'm not able to push it through. So it's kind of a, you know, you got to do it a couple of times when you're figuring out your barrel twist rate to make sure that you have enough friction on there where it's going to engage the right way on that rifling. Oh, actually, hold on, I've got something I can use as a vise right here. Get that under. Throw this side plate back on real quick so that that firing pin doesn't come out. all that is secure now, so I'm going to get this flag up at the 12 o'clock position so I can watch the rotation of it. Get to that friction buildup point. And start pushing through. Ooh, too fast. Too fast. So right there, too much friction because it took way too much effort to push this patch through. Good again. Put my finger back here and get this up in 12. So I'm at the friction point. Slowly push through. Oh, too much again. There we go. That should be better. There we go. Now I'm getting the rotation I'm looking for. So let me back it off the friction point. 12 o'clock. Now I've seen that the flag rotated about 1/8 of an inch. Probably looks like more on that camera because my hand's in the way. So when you pull it out and measure where the end of that mark was, keeping into account, especially because the cleaning patch came off, so there was a little bit of buildup there. So that should count in the measurement as well. Rotate to my mark and measure from where the front was. Drop it out a little bit. So here I am just shy of 2 inches, but again, with a little bit of buildup of that cleaning patch to build the friction, you know, that's going to account for a little bit of your measurement because that's, you know, a pretty thick amount of patch there. So right at around 2 inches, rotating 1/8 of an inch at 2 inches, you do the math on that for a 2-inch barrel, and that would equal a 1/16 twist rate for this barrel.